day everyone, this is Margie Lutrago, BLIS 3E. In this video, I will present
Chapter 9, Analysis of Data. Data analysis is the process of systematically applying statistical and/or logical techniques to describe and illustrate, condense and recap, and evaluate data. Role of statistics. Statistical analysis may be used to accomplish for basic purposes. 1. Statistics may indicate the central point around which a mass of data revolves. 2. They may show how broad or diverse the spread can be for a mass of data. 3. Statistics may reveal how closely or distantly certain features within the mass of data are related, as well as whether a relationship even exists. 4. They may indicate the degree to which the facts might have occurred by mere chance, or whether there is a probability of their having been influenced by some factor other than pure chance. Role of statistics. The basic purpose of statistical analysis is to summarize observations or data in such a manner that they provide answers to the hypothesis or research questions. Cautions in using statistics. Just to keeping in mind that the statistical analysis cannot do the interpretation, the researcher should be aware of other concerns in using statistics. For example, the nature of the data to a large extent determines the statistical techniques that can be used legitimately. Steps involved in statistical analysis. Regardless of the specific techniques or tests employed, there are certain basic steps common to virtually all statistical analyses. Those steps will be discussed briefly before taking a more detailed look at the major types of analysis. The establishment of categories. In order to organize and analyze the data collected for a study, it is necessary to place them in categories. The actual categorization of data takes place during or after the collection process. 1. The set of categories or values for any one variable should be derived from a single classificatory principle, which is determined by the research question or hypothesis being investigated. 2. Each set of categories should be exhaustive. It should be possible to place every observation in one of the categories of the set. 3. The categories within each set should be mutually exclusive. This means that it should not be possible to place a specific observation correctly in more than one category. 4. The development of categories should be based on a sound knowledge of the subject matter and an anticipation of likely responses. Coding data refers to the process of transforming collected information or observations to a set of meaningful, cohesive categories. It is a process of summarizing and representing data in order to provide a systematic account of the recorded or observed phenomenon. Analyzing the data. Descriptive statistics. Once the data are ready to be analyzed, the researcher can choose to utilize descriptive statistics, inferential statistics, or both. Looking first at descriptive statistics, which have been the predominant type of data analysis employed by researchers in library and information science. Analyzing the data. Inferential statistics. In contrast to descriptive statistics, which simply summarize and describe the data, though, as indicated above, they can at least suggest relationships. Inferential statistics can perform certain more sophisticated functions. Parametric statistics. Most important, parametric statistics require the assumption of a normal population or distribution. When the data of a normal distribution are plotted, they should produce a curve that is symmetrical. Its mean, median, and mode should all coincide, and there should be a constant area or proportion of cases between the mean and an ordinate, which is a given distance from the mean in terms of standard deviations. Some examples of frequently used parametric tests include the following. 1. Z-test. This test, using standard scores, tests the difference between a group's results and the results that would be expected due to chance alone. 2. Students t-test a test that can be used in place of the z-test where theory is still only one group, but where, in contrast to the z-test, the standard deviation of the population is not known. 3. Difference of means, a commonly used statistical test which utilizes the t-statistic and which determines if the statistical difference between the mean scores of two groups is significant. 4. Analysis of variance, a statistical test which represents an extension of the difference of means test. It utilizes the f-statistic, and it tests for differences among the means of more than two samples or groups. Analysis of variance, ANOVA, can be used with only two groups but would produce the same results as a t-test in that case. Multiple analysis of variance, MANOVA, is designed for situations where one needs to test relationships that involve more than one dependent variable. 5. Post-HOC tests. These test the statistic significance of differences between group means that have an overall difference calculated after an ANOVA or a regression analysis has been done. A. Tukey's honestly significant difference test. This test is used to examine the pattern of mean difference and can be used with more than two groups. The score is the within group variability and is part of the ANOVA result. B. SCAF test, a test of significance used for multiple comparisons of means in an ANOVA. It is good for comparing unequal cell sizes and tends to err on the side of 6. Reliability coefficient, a statistic that indicates the reliability of a measurement, that is, a test, scale, etc. They range from 0, completely unreliable, when observed variance is attributed to random error, to 1.0, completely reliable. A. Cronbach's, a measure of internal reliability or consistency of the items in an instrument that have more than two answers, such as Likert scales. B. Coder-Richardson measures the internal consistency or reliability of tests in which items have only two possible answers, such as size, or no, or true or false. 7. Pearson's product moment correlation coefficient. This test generally is referred to as simply the correlation coefficient. It measures the degree of linear association between two variables, or the extent to which changes in one value correspond with changes in another value. 8. Regression, a type of analysis that, as is the case for correlation, can burst for descriptive and inferential purposes. Non-parametric statistics. Non-parametric statistics are considered to be distribution-free. That is, they do not require the assumption of a normal population, and, therefore, are often used with smaller samples. 5 common examples are as follows. 1. Chi-square test X. This test is useful for determining if a statistically significant relationship exists between two categorical variables. 2. Mann-Whitney U test. This is one non-parametric equivalent of the difference of means test and is used to test for a significant difference between two groups. 3. Wilcoxon sign test. This test can be used instead of the Mann-Whitney when the data are not symmetrical. 4. Spearman rank order correlation, or Spearman's. This is a non-parametric correlation coefficient that can be calculated for ranked or ordinal level data. 5. Kruskal-Wallis test, a non-parametric alternative to analysis of variance. It is appropriate when one has a number of independent random samples and an ordinal scale level of measurement. Selecting the appropriate statistical testers has been indicated for most of the examples given above. The various statistical tests must meet certain conditions before being appropriate for use. Cautions in testing the hypothesis. In using statistics to test hypotheses, one must always keep in mind that statistical inferences are based on probability, and one can never rely on statistical evidence alone. Statistical software package bioservice is an efficient technique for analyzing large amounts of data. An example of such a statistical package is BNT software. Analysis of non-quantified data is worth noting briefly at this point that not all research data are susceptible to quantification, and such data do not lend themselves to statistical analysis.